Hello students, I am Dr. Archana Sharma from Kite Group of Institutions. Students, you all are very much familiar with derivative. The term derivative, this is very well, this is tangent, slope of tangent or rate of change, like this. And you also familiar with the process of finding derivative. You can find first order derivative by first principle. You can also find then second order derivative and up to and so on. So today lecture I am taking this lecture for successive differentiation. We will discuss here this topic. So this is successive differentiation. Well, first of all, you must know what is successive differentiation. If we have a function of x and we differentiate this with respect to x, again we are getting the function of x. It means we are getting dy by dx equals to f dash x, and f dash x, this is again a function of x. So we can find its next derivative. It means we can differentiate this again. We got y2. If y2 is again a function of x, then we can differentiate this again. We are getting y3, y4, y5 up to and so on. So this process to finding y2, y3, y4 up to and so on, this process is known as successive differentiation. If we have y equals to e to the power ax, and differentiating this with respect to x, we are getting again function of x. It means y1, this is equals to a e to the power ax, and again I can differentiate this and getting y2, this is a square e to the power ax. Like this, you can see clearly here we are getting a pattern here, and to observe this pattern, we will observe this pattern, and on behalf of this pattern we can write the value of nth differential coefficient. We will say differentiating successively, and the value of nth differential coefficient will be a to the power n e to the power ax. Now we will prove some standard formulae that will help you to solve the difficult problems. Let we have y equals to 1 upon ax plus b. It is in denominator we can see here we have a polynomial of first degree. This will help you to solve the quadratic, biquadratic or cubic equations if you have in denominator. So we are proving this as a formula y equals to 1 upon ax plus b. If we differentiate this term, we are getting first order derivative y1, and this has value minus 1 to the power 1 into a divided by ax plus b raised to the power 2. And again y3, this is again differentiating, we are getting y2, and this has value minus 1 to the power 2, 1 into 2 into a squared divided by ax plus b to the power 3. And y3, y4, y5 up to and so on. And you can see we are getting a pattern, and we study this pattern, then we can write this differentiating successively. Nth differential will be minus 1 to the power n into n factorial a to the power n divided by ax plus b raised to the power n plus 1. We also prove some formulae for trigonometric terms. Let y this is equals to sine ax plus b. We differentiate this with respect to x. So then first order derivative again in terms of cos, but we will change it in terms of again sine by changing its quadrant. It means the cos will be changed. When we add angle pi by 2 in its angle, then it will becomes again sine. Then we will again differentiate this, it becomes cos, and we will change it in terms of sine. Then we can see here clearly we are getting a pattern, and on behalf of this pattern we can write this differentiating successively. We can write the nth differential coefficient, and what will be the nth differential coefficient? It has value a to the power n sine ax plus b plus n pi by 2. Similarly, we can find the nth differential coefficient of cos ax plus b. It will be a to the power n cos ax plus b plus n pi by 2. And in particular, we can find nth differential coefficient of sin x and cos x. It will be put a equals to 1 and take b equals to 0. then this term will be another differential coefficient of cos x and another differential coefficient of sin x. They will be another differential coefficient of cos x is cos x plus n pi by 2 and another differential coefficient of sin x, this is sin x plus n pi by 2. Similarly, using the successive differentiation method, we can find another differential coefficient of log ax plus b, and it has value minus 1 to the power n minus 1 into n minus 1 factorial a to the power n divided by ax plus b to the power n. And in particular, if we take a equals to 1, b equals to 0, then the another differential coefficient of log x, this is equals to minus 1 to the power n minus 1 into n minus 1 factorial divided by x to the power n. Similarly, if we will prove one more formula here, this is for y. If we have y equals to e to the power ax sin bx plus c. If we differentiate this, then we got y1, this is equals to a e to the power ax sin bx plus c plus b e to the power ax cos bx plus c. And you can see here, if we put some particular value for a and b, then we will reduce this as an in terms of a trigonometric identity. So we are putting here a equals to r cos theta and b equals to r sin theta. Where if we put these values here, then y1 will be r e to the power ax cos theta into sin bx plus c plus sin theta into cos bx plus c. We can write this r e to the power a theta sin, we can write you can consider this cos a sin b plus sin a cos b. It means y1 will be r e to the power ax sin bx plus c plus theta, where r has value under root of a square plus b square and theta has value tan inverse b upon a. Similarly, we can differentiate this again and y2 will be r square e to the power ax sin bx plus c plus 2 theta. And if we differentiate this successively, then another differential coefficient will be r to the power n e to the power ax sin bx plus c plus n theta. And similarly, we can derive the formula if we have function e to the power ax into cos bx plus c. Then the another differential coefficient will be r to the power n e to the power ax cos bx plus c plus n theta. And if we put here a equals to 1, b equals to 1 and c equals to 0, then another differential coefficient of e to the power x sin x, it will be under root of 2 into e to the power x into sin x plus n pi by 4. Now we take some examples. You will feel more comfortable. Let y equals to x to the power 4 divided by x plus 1 into x plus 2. Here you can see clearly this is, first of all, this is an improper integral because numerator has more power than denominator. In numerator we have biquadratic equation and in denominator we have a quadratic equation. So this is an improper integral. First of all, we will divide numerator by denominator and we will make it proper. Now this is y equals to x square minus 3x plus 7 minus 15x plus 14 divided by x plus 1 into x plus 2. In denominator, we have a quadratic polynomial. First of all, we will factorize this. In linear factors, you can see here, this is already linear factor. It was already linear factors, x plus 1 into x plus 2. So make here use partial fractions, and after partial fraction we can differentiate this n times directly, and we got the another derivative. This is minus 1 to the power n factorial 1 upon x plus 1 to the power n plus 1 minus 16 upon x plus 2 to the power n plus 1. We can take one more example. This is find another differential coefficient of e to the power 2x into cos square x into sin x. In such type of problem, first of all, reduce the power of trigonometric term. Here, as you can see, we have the cos square x. So make its power 1 by using formula cos square x, we can put 1 plus cos 2x upon 2. And also we have some problem here. We are getting a term sin x into cos 2x. So reduce this product by using trigonometric identity 2 sin a cos b. We will use here, and we got the term this. The term y equals to e to the power 2x upon 4 into sin x plus e to the power 2x upon 4 into sin 3x. We derived the formula for the same term, so we will use direct formula here, and we got the another differential coefficient. This is 5 to the power n by 2 e to the power 2x into sine n tan inverse 1 by 2 plus x plus under root of 13 to the power n by 2 e to the power 2x sine n tan inverse 3 by 2 plus x. And this is the another differential coefficient of e to the power 2x cos square x into sin x. This is all about this lecture. I think this lecture will help you. Okay, thank you very much.